And we're live yet again. Hello, everybody, and thanks for coming back to the HVAC 2.0 show. Gathered here with a couple of people. We got Ken and we got Jason Cecil with us. And I guess we're going to be talking load calcs today again.
Still.
Thanks for having us.
Well, I guess y'all want to start into this YouTube video and just kind of we can just kind of riff on some things because I think this was pretty interesting into seeing because it's very or it's a very common topic among the Facebook groups in HVAC talk. Anywhere people are discussing HVAC, load calcs is something that's constantly discussed. And there's so many little variables of blower door, no blower door, energy use, no energy use, so on and so forth. But here's something that, and a lot of people watching, you may have seen this, you may have not, but this YouTuber he's just a homeowner. He doesn't have any technical side in the HVAC industry whatsoever. Basically, wanted to find out how oversized is my system, and I will show my screen here. So this is his one of his videos here. He did two where he kind of had a follow up on some things that were brought up in the comments after the fact of him making. I believe this was the first one. Yeah, this was the first one, and then he had some follow ups on this one. And yeah, it was pretty interesting because a homeowner basically was able to perform a far more accurate load calc on his own house than what 98% of contractors could do out there, maybe 99%. What would you say, Ken?
I wish I still had the link for one of the contractors near us on their webpage. They had so many square feet per ton.
Oh yeah, yeah. I had just seen there was a local ad that was being ran from a company that's close by. They were using Upfrog, and it was that typical, pricing online. So you go through, you tell them what, figure out what size you need, and it was showing like, if I remember right, it was a house that was 2,000 to 2,500 square feet was calling for a 4-ton unit is what they were prescribing. And it's like, those are the types of companies out there. That's the level of, competence.
And the big box stores too.
Oh yeah.
They'll
Oh
show
yeah.
you. Yeah, they'll just add how many windows, how many bedrooms, how many square feet. Here you go.
Yes. Yes. And I mean, and it was kind of funny because this guy, he is outside of the industry. He is, and I mean, he basically come to the conclusions that a lot of us within the industry have known for a while, that most people don't know what they're doing. And he's like, why do I have a furnace in my house and it's 4 to 5 times bigger than what it should be? And which some of the things that was funny about this is, he really approached his load calc from multiple different angles. He basically did his own comfort consult onto himself, and how, when we perform a comfort consult, we basically hone into the load calc from multiple angles. We're looking at energy use. If we have run times, we look at that. We look at set points. We look at, manual J. He didn't do a blower door test, which that's one factor that we throw in at the comfort consult, but he did basically everything else of really looking at honing in on that. He has an Ecobee. Let's see, so I can find. Is it this one or is it the other one?
One thing would
There was
be
one.
interesting to know is how long did it take him
There
to
it is.
do this? Is this something that the majority of homeowners would be willing to do?
Oh yeah, and there. Well, I mean, looking at Ecobee run times, I mean that is doable by anybody.
Yep.
Now the level that he went, nobody, very few people are going to do that because he went. What he did as another verification method is he bought a bunch of space heaters and had uh, basically an energy monitor for each individual space heater, and then he turned his system off when it got down to his design temp. I think he said it was like -15 or something. He's in Chicago, and had space heaters in all the rooms, and just basically was like, okay, I know the wattage of all my space heaters, therefore I can calculate how much heat they're producing, and then look at the actual energy of them, turn the thermostats to whatever they need to be to match his set point, and then just let them run and see what happens. And he was like, okay, well, I was able to determine that with X amount of, I mean, I'm trying to remember how many he used. I believe he said it was like 7 space heaters at 1,300 watts is what they were doing each. And he was able to maintain his house temperature with all those space heaters at -15, and then could just kind of back in to going, okay, it used X amount of energy to do that. X amount of energy equals, however many BTUs. And then how does that compare to my furnace? And how does that line up with the runtime data that he had on his furnace previously? And so he was able to really triangulate in on what his actual load calc is doing this, which was pretty interesting to see, because really the conclusion of his videos was basically what we've already kind of come to, is that most systems are oversized. Even people who do manual J calculations, they're overshooting the heating load, and the true heating load is far less than what anyone would even imagine. And then he kind of ties it into when he replaces his furnace, he's going to go to a heat pump, because when you actually know the true load of what the house is, then it's easy. It makes it a lot easier to go, okay, I can see how we can make this jump to a heat pump, because the load is far less than what we actually thought it was.
Yeah.
And that's, I mean, especially in his climate, that's where it makes it easy to make that jump from a furnace to a heat pump. Because if you're looking at your manual J, if you're doing one and you're seeing 80,000 BTUs for this heat load, that's a scary number to try to put what did he say? That is true. But let's see, what do you got here? Yes.
Yeah. He talks about common walls.
Yes.
And for those who are listening, this is I've put in the chat, Tanner, Technology Con Extras is this YouTuber. So if anybody wants to find him.
Yeah, I believe that's his second channel, like the small channel. His main channel is Technology Connections. That's the one that has the most.
Oh, okay.
Yeah, because his main channel has 2.2 million subscribers, so he's a big channel.
Yeah.
He's more of a technology focused channel, but
yeah, this one's only 349,000 subscribers.
Yeah, only 300.
A mere, yeah. I'm sure he won't mind having his name out there, though.
Oh yeah, I mean, we're glad to help out in any way that we can. Really get his channel up and going. But yeah, and so it really was. I mean, it felt like to me that a big point of his video was that your heat loads are actually a lot less than what you think they are, and heat pumps are okay in cold climates. Seemed to be like a good conclusion that he was kind of coming to. And what I liked about his video is he was really driving that point home by really showcasing what his actual heat load was. And
verifiable.
Yep. Yes. And I mean, that's just one of those things. Of people in cold climates, that's the easy way of making yourself comfortable with a heat pump in that regard, of just looking at run times. Because if you anticipate 80,000 BTUs as a heating load, and then you realize, oh, at design temp, my 80,000 BTU furnace is only running 50% of the time, that's a big light bulb moment that makes it easy for you to go, oh wow, okay, this is totally different than what I expected. Maybe a heat pump isn't as difficult.
Yes. It comes down to data collection.
Yes.
Because so often, if you think that it's as simple as the almost universal 500 square feet per ton for cooling, and you find out that that's not the case, why is it not the case? It might be justified in asking, why are people using that? And what's a better way? What can I do as a homeowner? Where can I go to find this information? How can I figure it out? So a load calculation is a method of narrowing the field, but without some specific measurements, specifically house leakage, you're you've got a pretty wide range to work with. If you'd like to narrow it down, you need to have more measurements.
Mm-hmm. Yes, definitely. I mean, it really
So for
comes.
us sales guys out here, tell us what's wrong with an oversized furnace other than comfort.
Extra
And obviously,
expense, the extra cost of the equipment,
Well,
and
cycling.
additional cycling, because it's cycling that places more wear and tear on equipment.
yeah. Well, I mean, it's one of those things that it can kind of really have a domino effect as you get, because the bigger system you get, what at least from what I've seen, it seems like the bigger system that you get, the greater odds that the ductwork is going to be too small, because the actual physical size of the house probably, like, the areas that you can run your ductwork doesn't really change. So if you're already constrained, you're constrained, and so odds are whatever size that can be fit is what's going to go in. And so you factor in oversized ductwork, you factor in all these other things. Well, cycling on and off all the time, that's more wear and tear. Um,
And
if you
waste,
Yes,
because it doesn't get to full efficiency for 10 minutes.
yes. And if the system is not operating right, to where the say the duct system's way undersized for what it should be, your static pressure's through the roof, you don't have the airflow that you need. Now you're probably going to be cycling on high limits, because if really, it's like the more oversized your unit is, the greater the risk of some of these other looming issues, like undersized ducts, cycling on limit, things like that are likely to happen. I mean, when your system turns on, depending on where your ductwork's at, obviously, if you're in an area where your ductwork is inside the conditioned space, it doesn't matter. But for the people that aren't, well, you've got to heat that ductwork up. So if you've got a far run on the end of the house, and for air to come out of that vent at a decent temperature to heat that room, if it needs to run 15 minutes, but the system shuts off at 10, you're going to have inconsistencies, in comfort there. Um, I mean, you
Did you
could,
have some things in mind, Cecil?
I was just thinking about, like you said, if the ductworks, if you had a 2-ton heat pump, I don't remember what he had on the outside, but if you only had 2 tons of ductwork and you're trying to cool off that heat exchanger and don't have enough, I mean, you could, you know, put extra stress on that heat exchanger. It's going to cause it to crack, I would think. I don't know.
That's certainly a potential problem.
mm-hmm,
But if that's it's probably safe to assume that the ductwork is not big enough, because in so many cases, when we have downsized equipment, we find that the smaller equipment is the right size. The ductwork was the right size for the house, but not big enough for the oversized equipment. So when you finally downsize, when the equipment gets replaced 18 years into the life of the house, all of a sudden it's quieter, it's more comfortable throughout the house. Uh, the humidity is reduced in cooling. So, yeah, I think it's safe to make the assumption that oversized equipment is usually on undersized ductwork, although that may be appropriate for the structure.
yeah, yeah. I remember I made a meme I put in the Facebook groups that kind of stirred some people up, where I said that uh, duct systems are not actually undersized. Something along the lines of duct systems not being undersized as often as people think they are. And the angle that I was kind of going at was saying that odds are the duct system's probably plenty big enough. It's just the equipment itself is grossly oversized. Um, a lot of people didn't quite, I guess, putting two and two together was a very difficult task for them, and so they had a hard time understanding that. But
Mhm.
anyways, but that is a commonality that we do tend to see of everyone that ends up under or reducing the size of equipment. The ductwork tends to work out. You know, it tends to
It's a whole
be
lot
big
better.
enough. Yeah,
Yeah.
because if there was a 4 ton in there and you're reducing it down to say a 2 ton or a 2.5, like that's a big reduction. So
Yeah.
you'd have to have some just massively, like they oversize the equipment so much that their undersizing of ductwork makes it okay for when you come back with the right size equipment.
Unless it's maintenance man installed, and then it's always
Yeah.
undersized.
Yes.
Mhm.
Or if it's a mobile home, then just good luck.
Yeah.
That's all I can say.
Yeah. So that raises the other question, and I'd mentioned it beforehand. In some jurisdictions, a load calculation may be a requirement. And what happens? How is that load calculation performed in order to satisfy that regulation? The answer is it's the answer is that the load calculation is pencil whipped to come up with the size that they want to put in.
Yes. Yes. I mean, there's that. There is just putting in numbers that that you think is okay and just slapping it, seeing what number comes out because especially some people that get new into like they're given software and they start doing these load calcs. There's this sense of overconfidence of when the program gives you a number that number's just inherently correct. And
Mhm.
so even so you don't purposely do it, but you throw in this garbage data that you feel like is kind of right, but you didn't really look at the house, you didn't really check a few things. It's just, oh, here's just standard construction, so it has to be right. That gives you a number, and then there's just this overconfidence in that number is right.
Yeah.
Uh, of course, there's also the fact that if jurisdictions, they're only going to be asking for only a manual J, which doesn't require a blower door.
Mhm.
And if you're doing a manual J without a blower door, I mean, it's garbage in, garbage out. So if you don't know what some of these numbers are, uh, then it's garbage. So what can we expect out of these, out of these load calculations? I mean, you're going to get exactly what you anticipate, and uh, and it's just one of those things of if there's no if there's no feedback loop for verification, if you're not looking at your run times after the fact, then you don't really know. And so the only way that you will know is if people call back and complain. And so if you don't have people calling back and complaining, I mean, there's no reason to think that it was wrong. So that's how it kind of that's how oversizing has become such a problem is because the abilities to really verify that you've sized correctly, that ability hasn't really been out for very long. When I say that, I'm referring to looking at your run times
Mhm.
easily, like with an Ecobee. Um, and so it's just become one of those things that, there was no way of really verifying. And so your only consensus was, hey, Miss Jones, we put your system in last year. How's it done? And if they say, oh, it worked great, we've had no problems, then everything seems fine. There's, as far as based on the information that you have, you sized it correctly.
That's the
That's it.
Dunning-Kruger effect.
Yes.
Yeah, just look that up in order to define it. It is a cognitive bias in which people with limited competence in a particular domain overestimate their abilities.
Yes.
So when you get a load calculation program and you run it and you say, okay, this is the perfect answer. There are no other answers. So until you've worked through your own competence level and understood the mistakes that you are capable of making, you're not in a good position to judge that.
Yes. And like in this comment right here, uh, videos like what this guy's put out, and among other things, there's a lot of talks in some groups on Facebook where homeowners can interact. Um, it's slowly becoming a common thing of consumers talking about performing their own load calcs. Now, is it a mass thing where you're gonna, have every other customer do their own load calcs? No, but it could be something that becomes a thing. There's
Yeah.
several people out there that's offering services to homeowners directly for this. So it's becoming a lot more readily available. So if you're a contractor who hasn't really done this in the past and you've just kind of pencil whipped it, and guesstimated, well, you know, those are going to be the ones where it's like, oh no, what's going to happen? Now, the question becomes, if you talk to a homeowner and they present you with a load calculation of what their house is, what do you do with that? Do you just take this load calculation for that it's correct and go, okay, well, it says that you need a this and this, and we're going to slap it in? Like, who takes that responsibility? What, you know, what happens there?
You want to go first, Jason?
Yeah, I mean, for me, that would be on their responsibility. I'll use your load count.
Yeah.
I'll avoid all responsibility for that.
We will be happy to install the equipment that you have specified. And the outcome of that installation is based on the specs that you gave us.
Yeah. I mean, what you could do is plot it out on the likely load range. Okay, here's your likely load range. Your load calc falls here, wherever that may be. Uh, how do you feel about that?
Mhm.
I'm making a lot of assumptions that this is correct. If we size to this and it's not correct, you're not going to be mad at me, are you? Having
Yes.
that type of
Would you
discussion.
like to do a static pressure test, a duct pressure test? Your duct,
Yes.
your duct work says that your equipment should be this size.
Mhm.
Likely load range says it should be this size, and your load calculation says something totally different. What size do you want?
Might there be legal ramifications? What if somebody specs 4-ton equipment instead of 2 or 2.5-ton equipment, and then a mold issue develops, and then they have health problems, and then they get lawyers involved, and they want to point the finger at someone?
Yeah. That is a common, when it comes to like what the title of this particular show is of if the homeowner wants an oversized HVAC system, what do you do? That's the initial go-to of the people who say, "Oh no, you know, you should go in and you should tell the homeowner that, listen, I am the King Almighty of HVAC. I know more than you'll ever know. You need to just shut up and do as I say, or I will not bless you with my work."
Mhm.
That's how some people look at it, and you shouldn't. Um, in reality, if that pans out that way of you put in an oversized system, mold forms, and uh, lawyers get involved, like you've screwed up so many times, so many different ways that didn't include putting in that 4-ton system, that it's your own fault because you didn't do your due diligence in reality. Because listen, if a homeowner says, hey, I've got let's say it's a 2,000 square foot house, I know it needs a 4-ton system. Okay. I would say, okay, well, what makes you think you need a 4-ton system? Dig it. Why is it that they're wanting this particular size system? See what stems from that. Do they have other concerns that is going on there? You can offer them, hey, now just so you know, when sizing equipment, you can run into some major issues such as building up biological growth like mold, things like that can cause some severe health issues. We have this service called a comfort consult we can offer, and we can verify and make sure that this 4-ton system that you're asking for is in fact what you actually need. In our experience, we've not seen a house where 2,000 square feet needs 4 tons of cooling, but it's possible. Who knows?
Mhm.
Uh, you can lay it out that way, have that discussion, and let's say, for instance, they insist. They say, no, your process is stupid. You're stupid. I know exactly what size I need, and I know it's 4 tons of cooling. Well,
How
then,
much ductwork do you have?
yeah,
Yeah.
you can go from that angle of, okay, well, we can do that, but what happens if the system's not functioning properly? If we start this unit up and it doesn't work right to begin with, are you going to be okay with that? Start hitting at some of it, because really what it comes down to is he is trying to tell you, I want you to install a 4-ton system, and I want you to take full responsibility for it. And if you let him do that to you while you install that system, guess what? That was
It is your
100% on you. Yeah,
responsibility.
that was that you took responsibility, so it's your fault. That's how that works. Um,
Also ask if they're putting variable speed or single stage.
Yeah.
yeah, but what it comes to, like, another thing that I don't think a lot of people do is lay out, okay, if we do X and Y occurs, then the next step is going to be Z.
Hmm.
Such as, like, if I was in that situation, and let's say somebody, they were dead set, I'm gonna have a 4-ton blah blah blah, uh, and I put that system in, I'm gonna leave them with a couple of cheap hygrometers, and I'm gonna say, hey, this right here, this reads out humidity. Uh, you size this equipment, and which I'm also gonna have this discussion before I even put the system in, but I'm gonna give them those hygrometers after we get done, because I'm gonna leave them knowing that it is their response. The same way it's your responsibility to keep your oil changed in your car, it's gonna be your responsibility to make sure that your humidity doesn't get above 50%. And if it does get above 50%, you can go buy you about 5 to 10 portable dehumidifiers
Hmm.
and start throwing them out, as many as you need to control it. And if you have issues controlling it, I can help you with that. We can throw in a whole house dehumidifier. We can do this. We can do that. But if this 4-ton system's too big, it may be something where we need to pull this system out again and put in the correct size system. But you're assuming all risk on that. Do you understand? If you have these types of discussions and then they do have issues, you always have something to point back to go, hey, what's happening right now? Remember, I warned you about this. So, as I pointed out before, then our next step is whole house dehumidifier, multiple portable dehumidifiers, new system, whatever it may be. It's like, as long as you always have something to point to go, okay, here's the next step for solving your problem, then you have a leg to stand on. I mean, you're not going to get caught up in things where you do work on the front door, but the back door is broke the whole time, and then they're trying to blame you for the back door. If it's something totally separate from the house, like, you're not responsible for everything unless you take responsibility for it. And you take responsibility up front before you ever begin any work. And so it's not that, you should be turning away all work if the homeowner is insistent on what size they need. It's that, no, you should have a decent process. You should have your own process on dealing with those situations. If you can't deal with those situations, you're not high and mighty and should turn away the work because, these peasant homeowners are just not good enough for your level of work. No, it's that you just don't know how to do it.
So it might be that the contract, in addition to having the 4-ton equipment that the homeowner specified, offering a whole house dehumidifier then and there, which they can decline. We can refer to that as a contingency plan, so that when they turn it down, now they have refused that part of the contract, which was what you recommended, uh, and now it's back in their court. Okay. Yeah.
Yeah,
Thanks,
which
Doug. So yeah, go with a smaller system and offer as an option some ductless systems that they could kick in when they needed it, if they felt they needed more capacity. And it may happen
yeah.
that in that case, before they may never, and hold off. Just offer the minis as an option to be put in later if they need it. If they don't need it, they'll be surprised and pleased.
Yeah, I mean, definitely if someone's requesting oversized equipment, especially if you sell the carrier line or train where you have electric reheat dehumidification,
Mhm.
that gives you a lot of buffer because those systems, they're going to dehumidify really well. It's just how much energy are you going to use having to do reheat to make up for the difference?
Yeah.
Not I mean, obviously, oversized system's always going to be bad. There is no, oh, just put in a high efficiency system or put in a green speed and it'll magically make oversizing not an issue. That doesn't exist, but it can blunt it.
Now, here's another thought. You better make sure you do a good commissioning process when you start that equipment up so that, as Jason has suggested, you have documented the static pressure. And then when it comes time to replace the first blower motor that fails, the distributor is likely to give you the blower motor, but then when it happens again 6 months later, and the distributor is reluctant to start give you more blower motors, you can say, look, here's why. And when the warranty is declined, then it falls back on the homeowner.
Yes. I mean, it really, it all comes down to, okay, Miss Homeowner, they're requesting blank. And then you say,
His homeowner.
yes.
Got to use the right pronouns here.
Yeah. Oh, we won't want to offend anybody here. Uh, we already do that enough. Uh, but I mean, it's having that discussion of, okay, Miss Jones, whoever, you're requesting blank system. Rather than sit and preach at them and tell them, this is a terrible idea. You need to do this and tell them this and that and blah, blah, blah. Instead of telling them what they should be doing and this and that, just ask questions and say, okay, uh, we could definitely do that. But just so you know, if this system were oversized, we could run into problems such as poor humidity control in the summertime. We could run into high duct pressure, which could make the system fail really often. And
Mm-hmm.
rattle off a few things like that and go, if we put this 4-ton system in and we run into these problems, uh, what happens then? And see what they say. See, are they going to be like, well, if that happens, then I guess we just have to deal with it because this is my choice. Like, I mean, are they going to accept that? Or are they going to say, which most likely they'll say, oh, well, then that's a problem. Like, I'm not having that. Then you go, okay, well, hold up a second. Um, I can't guarantee that if we put in the system that you're requesting, that these problems won't happen because these are common problems when it comes to oversizing. What do you think we should do? Like you're throwing it in their court,
Yep.
basically. You have to have that uncomfortable discussion. And here's the thing, it's kind of funny. People will think that you shouldn't have this discussion, but the alternative should be that you should just walk away. So it's like walk away and get nothing, or rather walk away and then some other crappy contractor comes in behind you and says, "Hey, sure, we'll do that." And now they're going to do some hacked up install. Like it if you're trying to be virtuous and moralistic, how is that route better? That doesn't make any sense. If we're as moralistic and virtuous as what we claim we are, we would have the difficult discussion to go, okay, if we do this, what happens when blank happens? Who are you going to be mad at? If we run into failing fan motors left and right, and the manufacturer voids the warranty because it was installed in conditions that weren't appropriate, and you start having to pay thousands of dollars every 3 years because the fan motor dies over and over, um, are you going to be okay with that? Are you going to be okay if you can't control your humidity and you start having problems like mold growing on your walls and such? You know, are we okay with spending another 7,000 on a dehumidifier while we're here so we can avoid that if we're going to put in this potentially oversized system? Okay, what happens if our dehumidifier doesn't function properly because the system's too big, because the ductwork's too small, and the duct pressure's too high? You know, you start layering some of these things in, and if they say I'm willing, like you make them tell you, okay, I'm accepting all of this responsibility for if any of these things go wrong, And I understand that if these issues go wrong, that the next step is, let's say it's the comfort consult, and that could likely lead to new equipment again. If you'll, I mean, the odds that you're going to have all this discussion, install this equipment, have those exact problems, they point fingers at you, and before you know it, you end up in court. I mean, what's the odds that
Well,
that's
we're way better off having this discussion before the installation rather than after the installation.
yeah?
Now
Well,
they're
that's
mad.
when you have to have it. That if
Oh yeah.
that's when you have to, because a lot of times, it, at least in my experience in seeing other people handle this, it always tended to be that there was this weird sense of, we want to tell you that you're going to have all these problems, but we also want to get to the sale, so we don't want to be, we don't want to say be too negative
Mhm.
about it. And so what it ends up happening is that the homeowner's expecting no problems because they weren't explicitly told that they could have problems. And then they have problems, and then you have the difficult discussion after they've already spent thousands of dollars on this brand new system. And that's where the when people think of this situation, that exact scenario that pops in their head, that's that layout or that scenario I just laid out of, you do the work, they weren't expecting it, then they have problems, and then you lay out all the bad news as to what happens next. That's when all the negative things really happen, and
Yeah.
it all came down to poor communication and poor expectations, really.
The comment that we've got down at the bottom shows that it is perfectly possible to have this conversation ahead of time and avoid the situation of bad choices.
Hmm.
That doesn't mean you have to insist. It's the homeowner's decision. But I can see a scenario where you might want to, you have the contract ready without any signatures and offer it to the homeowner, let them read it. And you may have the clause, the option for the dehumidifier, the option even for smaller equipment, and say, now, before we sign this, as a responsible homeowner, you want to read this contract with all of the terms. And if anybody's ever had any, well, Tanner, you own a house. Jason, you own your own house.
I do.
Okay, yeah, we're in our second house, and I'll be perfectly honest. I didn't read all of those papers at the closing. The the lawyer explains, it tells me what's in this paper, and I say, okay, you know what's in it. I hope my contracts for the customers are not as lengthy as that. I would like you to know what's in this before you sign it. I haven't signed it yet, and I want you to know what the options are, what could happen before we enter into this.
Yeah, and which, as far as covering yourself on the legal end, that's exactly what you should do. Which, I mean, everyone should have a contract that homeowners should be signing anyways.
You don't want to
Um,
find yourself in court. You
yeah,
never want to find yourself in court over one of these.
yes, but the like, it seems like that the outlook difference or the problem of it is that when this discussion comes up, it all comes down to, oh well, how could you defend yourself in court? And it's like, well, if our whole mindset of this is that how are we defending ourselves in court, well then we failed to begin with, because our real outlook should be, how do we avoid getting to court to begin with? And
Exactly.
that's where having those discussions, like if you do that, you're not going to be ending up in court, you're not going to have to defend yourself.
Mhm.
uh it's just one of those things of handling it properly. Covering yourself on the legal end, that should be a given. Like, you should be doing that irregardless, even if you're putting in the right size. Do your due diligence on that end. But when it comes to avoiding to getting to court to begin with, which really, what does that mean? All that means is, how do you keep your customers happy? How do you avoid having extremely pissed off people at you because of poor outcomes? Like, that's the real thing that you should be avoiding. And managing that and having those conversations and having a questions-based sales process, that is how you avoid getting to court. That's how you avoid having mad customers and having happy customers. Because I mean, you how many people in our group has had a situation of somebody just has to have it a certain way, they do it that way, the homeowner goes, well, that didn't work, I need you to come out and do it again and fix it. They fix it, and the homeowner's thrilled, even though they had to pay 2 times to have something done because
Mhm.
they chose the wrong thing to begin with. But they were just explicitly told, they knew up
They
front, hey,
knew
this
it
is
was
your
their
thing.
decision. Yep.
Yeah, this is on you. Like, I don't know what's going to happen, and if blank happens, we may have to change it out again. And when you do it that way, it's a totally different dynamic. You don't have that, finger pointing issue that everyone's so used to.
Blame.
Because
Yeah.
yeah,
We don't
because
want
of
blame.
yeah. Well, because everyone's so used to going into something, and they're the expert. They should be there to tell people exactly what to do and exactly how to do it. And when you do that, you're accepting all responsibility. That's just how, if you're the expert that has all the knowledge, that knows everything that needs to be known to make this decision, they're looking at you like, "Oh, I'm putting whatever you say is what I'm going to do, and I'm expecting what you do to be correct."
Mhm.
And so, and at a free quote, I mean, that's not what we're there for. You know, if they're looking for a consultant to be the expert to do the testing, so that way I can give you really accurate, assumptions on what you should do. Well, unfortunately, you're gonna have to pay me to do that. That's called a comfort consult. We have a whole process for that. But if it's not worth the money, well then we can work together on guessing at this however you want to.
Let's put our heads together. Adult treatment. We talk to them like adults. That's been said before. And Jason, did I call you Ronnie before? I apologize.
I don't know. I've
No,
been called worse, I'm sure.
I think I did. But Tanner,
You
what
know,
was that?
I've got a friend that he sells in Colorado.
Uh,
Around here we're in the South, in South Carolina, North and South Carolina, and a lot of the bigger companies are concerned about mold, and sizing, too
Hmm.
large. So that's a big concern of the larger companies. In Colorado, it's different, because of I guess the humidity is so much lower, they're not really worried about mold. So they just make it clear to the homeowner if they want to go bigger, they can do that. But we may have to come back and replace duct work, or you may start going through blower motors,
sure.
and we're not going to take responsibility for that if you want to go bigger. So I mean, they're not following the HVAC 2.0 process, but I think if they did, it would be even more clear, and they don't have quite as much risk because of the mold or lack thereof in
Yeah.
your environment.
Yeah. I mean, you may, in those climates, you may not have the risk of mold, but you're still going to have the risk of just an uncomfortable house.
Yeah.
Because I mean, look, on the heating side, you don't really, unless you have a humidifier, or depending on, you know, what your set points are. I mean, you can have a mold issue during the wintertime. It's not impossible, but it's not as likely, or it's not as big of an issue it is in the summertime. But you still have a lot of issues in the wintertime when it comes to just comfort. If you have an oversized system, it's going to cycle a lot, and your house is going to be very inconsistent. Your uh, it's going to
I,
feel.
I
Go
think
ahead.
there's one of the videos that you had that showed, the registers closest to the furnace were, you know, satisfying the thermostat within 3 or 4 minutes, and it didn't have enough time to get to the far ends of the house before it shut off. So those extreme areas just never got any heat at all.
Yes,
Uh,
that, and you don't get any mixing. I mean, really, the majority of perceived comfort doesn't come from the air temperature; it comes from the surface temperatures of everything around you. And so, really, what you're actually aiming for is for your system to heat or cool the surfaces on the outside of the house, or just really the surfaces in the house in general, get those surfaces within a certain temperature. And that's how you really get that comfort. If you have an oversized system and it cycles consistently, you don't get those surface temperatures where you actually need them to where it feels comfortable. And that's where, you can have those times where somebody says, well, I keep it on 71, but I still feel cold. Why do I feel cold when the temperature's, when it's satisfied? And issues like that is where that can kind of stem from.
I think the best example of what Jason was saying is a mobile home
Mm-hmm.
with which always has poor ductwork, and the room closest to the furnace is the teeny tiny bathroom. And
Yes.
so what do? They close that register,
Yes.
which means now that if they have, let's say they have 8 registers in the house, they've cut off 16% of the airflow by closing that register. And it simply cannot make it comfortable that way. So for anybody who's dealt with that sort of a distribution system, just apply that to the bigger house. It's the same situation.
Yep.
Longer run times equals greater comfort.
Yep. I mean, and that's what it all comes down to. And to kind of tie it back into, you know, that first video that we showed, I mean, that was one of the things that he was finding out was that, I mean, a homeowner's figuring it out themselves of going, hey, why are most systems massively oversized? And so, I mean, it's a problem, and it's just who's gonna, you know, who's gonna be the one to actually point it out and talk about it, point it out and fix it.
Yeah. I've gone into chat to
Yeah.
read the comment. Oh, which is showing it with it's the use of the range for sizing. And I think an important part of that comment is we've already discussed, this is in the conversation with the homeowner, we've already discussed that the 2 biggest reasons people are uncomfortable in their homes is because of grossly oversized equipment and undersized ductwork. What size unit would you like?
Mm-hmm.
So when you ask that question and look them in the eye, who's accepting responsibility? It's the person
They
who
are.
the person who says this is the size I want.
Yep. That's it.
Yep.
And especially if if you ask them, hey, would you like us to check static pressure or duct pressure rather?
Yeah.
I mean, if you get that information, I mean, that can tell you a lot as well. And you can, if they are saying no, actually, I want this 4-ton system. I mean, you can with
Yeah.
basic
It'll
fan
take me
law.
15 minutes to perform this test. Would you like to find out where we stand right now with this static pressure issue before we take the plunge for your multi-$1,000 investment in new equipment?
hmm And then once you do take that test and see what it currently is, I mean, the fan laws are pretty basic equations. I
Mhm.
mean, you can put together. If I had it on hand, I would show it, but I don't have it on hand. Of you can predict what the static pressure will be when you change the size of the system. Look at, okay, I check static pressure. What's my actual airflow of this system?
Mhm.
If I bump up in air, if my static pressure was, say it's zero point 0.6 currently or 0.6, zero point 0.7, and it was flowing 800 CFM, okay, well, if we bump up from 800 CFM to 1200 CFM, what can we expect that static pressure to be? You could do that and go, hey, just so we kind of did some checking. If we were to put this size in that you're asking, the duct pressure is going to be extremely high. It could be very noisy. The fan motor could fail immediately, and uh, unfortunately, since we know that this is the case, it'll void any warranty on our end. The manufacturer may warranty it, but we can't come out and replace it for free.
Yep.
Yes. So the likely load range, right now, it is not auto-populated in the sense of that you have to actually manually enter in what that range is in the report. But in the report, it will show them, here's the green, yellow, red, and here's the 2 points of your range for the load, and then that will be come out in the report when you purchase it, and that's what you will show the homeowner to say, you know, here's the range estimate for your house of your size. If you have a good house, it falls within this green. If it's a bad house, it falls within the red. And there is a spreadsheet you can jump to that is also there that you can just punch in some basic information to get this load range, but you still have to manually enter in what is the bottom range, BTU, what is the top range BTU for it to actually show that.
Mhm. Yeah, the HVAC 2.0 free quote process does not do the load calcs for you.
Yeah, if air sourced equipment is currently there, I'm sure there's probably some like very oddball scenario where it makes sense, but I can't think of a reason to go to hydronics if it currently has air sourced. I can think of several reasons to go from hydronics to air sourced, but no reasons to go from air sourced to hydronics. Uh, Anyone else have any thoughts on this?
Throw in some input. And it is, as it states, it is more expensive. So that's something to take into consideration. Yeah. Might there be other benefits to that too?
Yeah, well, it's when
You've
you
got
start doing things with water, you're going to require chemical treatment. You're going to have a lot more potential leak points.
Mhm.
What we got here? Oh yeah, and I mean, dependent on what you're comparing it to, I would not say that it is an upgrade going from forced air to hydronics. Uh,
Are the risks worth the potential benefits?
yeah, well, it's like depending on the amount that you're going to spend. Um, if you can get top of the line heat pump, what's gonna outperform that at that cost? Basically nothing. Like the only scenario really where an air source heat pump, like a high end inverter heat pump, is gonna be a problem is if it's a house where getting ductwork is impossible. So if it's a pre-existing hydronic system, there's no room to put ductwork. That's the only scenario where that would be you know an issue. Of course,
Mhm.
then your only option is mini splits. Mini splits have their own problems. Um, but if you already have forced air and you already have your ductwork, it is not an upgrade. Like you don't really gain very much, or you don't gain really anything at all. If anything, you're losing a lot going from that forced air with the option for high end heat pumps to hydronics. And I think really probably the closest uh, case to be made would be geothermal heat pumps. But then that's a whole nother thing of, okay, how much money are you spending there? What's your payback period? And what is the odds that it's going to get screwed up? What happens if the loop wasn't designed properly and it needs to be redone? There's so many things that could go wrong there that it really just comes down to really simple is better in a lot of sense because simple means it's going to be like you can have more repeatable outcomes and you can have really good outcomes. And so if you can do that and keep it simple, at the end of the day, that's better.
I just find geothermal equipment is too darn cramped to work on.
Yes.
It's a pain to work on it.
And thank you for getting that.
Hey, there we are.
That is like I said, it's a simple formula. So, put that into a Google sheet to auto calculate and use it. I mean, that's if they will pay for the duct pressure testing, uh, that can be very beneficial if
Ready.
if they're insistent on larger equipment, use that to show them, hey, are you sure you want to do this?
I'm pretty sure I saw that on the whiteboard of the Big Bang Theory one time.
Exactly.
Yeah.
This doesn't mean that we don't give them help making their deciding decisions. It just means it's their decision. That's the key thing, is it's their decision. Because in the day, it's their money, their decision. Treat them like an adult, not a kid. Yes. I mean, you can do that. It's just, again, it's getting into that area of, is the juice worth the squeeze? Because the more moving parts, the more complexity, the more things that can go wrong. There's a lot of things that can compound there that really makes it boil down to just first principles thinking of going, is that even worth it?
Mm-hmm.
Of, what are we losing by leaving all air sourced to air to water, and what is gained? And in my opinion, unless I'm like I said, it is possible that there's some weird scenario that I'm not thinking of or I'm unaware of that is possible, but I don't know of anything.
Yeah.
Let's see what question we got here. So you will have to specify the likely load range. You can think of it really, and if you want to use starting out, the reason where we kind of come to the likely load range is a lot of us have done enough comfort consults where we've done blower door testing. We have looked at run times, and we've just seen houses work and watched houses function to where we kind of got to the point where, okay, a particular type of house of a certain size, we know it's going to fall within this range of sizing because, if it's bad, it's going to be on this end, or if it's good, it's going to be on this end. And then we go test just to verify, essentially. And some of those verifications are things about the house or things about the homeowner, because those are two variables that you have to look at. Um, so, with that being where likely load range come from, of just being okay, we recognized where good houses and bad houses tend to be, and that's created a range for us. You can also do it in a same sense of just going into your load calc software and go, okay, here's the house. If I were going to model this house, because we're making assumptions unless we're doing all the testing, and definitely don't do the testing for free. Nobody values free consulting. They just take your information and run with it and go to someone else to find it cheaper because they just don't care what you did for them. So you're going to be making assumptions. So look at what those assumptions are that you're making and go, okay, what is worst case scenario and what is best case scenario?
Mm-hmm.
That creates you a range, and then that can be your likely load range. It is better for it to be uh, fairly wide. Like, you don't want a likely load range of going, okay, it's somewhere between 2 and 2.5 tons, unless you are, you know, testing some things. And in my opinion, in order to be accurate enough to get the likely load range within a half of a ton, you should be doing a lot of other things. And if you're doing those other things, you should be doing consulting, paid consulting, not a free quote. So it's drawing that line of where to go. So uh, starting out, if you're in the 2.0 software, I would recommend trying out the spreadsheet that is attached there to where you can auto calculate it. To fill it out for yourself, like I said, go into your load calc software, you know, load out your house, change the aspects to where, okay, of the things that I don't know, what makes this house in worst case, what makes the house in best case, and
Mhm.
then look at what that range is and use that to kind of familiarize yourself. Because in reality, since you're not checking every single thing, we're making assumptions to some degree. There it is.
Yeah.
We're making assumptions to some degree. And so by making those assumptions, we want to go, okay, if we were going to miss this, uh, what type of, we're basically looking at what type of error margin are we working with when it comes to sizing the equipment. And then you're just illustrating this error margin to the homeowner to go, here's roughly where you're at, and having the discussion from there. So, but that's just kind of a, I guess, a rambling of why that is and how I kind of view it and what way I see it, anyways. Would you add anything to that, Ken?
Nope. I like that.
So, like I said, here's the software or the spreadsheet rather. Sorry, um, and this is just eventually we would like it to be where we can build this off of energy usage intensity, where you can just punch, throw in what their usage is.
Mhm.
Um, but let's see. It is, well, it's not really a rule of thumb tends to be a, some it's specified, but it's specified in kind of a,
It's
not sure.
overly broad. Rule of thumb is overly broad. We're narrowing it down with this. This does
Yeah,
the spreadsheet does have some parameters which will affect uh, the the output for the estimated load calculation. This perhaps that's the term. This is an estimated load calculation. It is not a thorough load calculation.
My understanding is it is a manual J with worst case infiltration and best case infiltration.
Yeah.
yes. Well,
There's
but it's not just, I mean, that's the biggest piece, but it might not necessarily be just that, because there's other factors as well that you may or may not know. Like, for example, you go into an older house, uh, how are you checking R value in the walls?
yeah.
You know, you can look and go, okay, hey, well, when was the house made? Okay, well, during that time, the code at that point in time was R11. Was it R11? You know,
Without opening up a wall, you won't know.
which, and so getting back to your question of getting the gut feeling to it, uh, like I said, I would play with this likely load uh, range calculator.
Mhm.
And if you don't have any load calc software, go to Cool Calc, which, granted, if you use Cool Calc, really only look at the cooling. Omit the heating because they lean so heavy into the fudge factors of Manual J that it makes their leading or their heating loads basically useless. It's going to be wrong. In my area, it's basically double what it should be every single time.
Double
So
to
if I
triple.
am going to look at it, I just cut it in half. So to me, that one's useless. But use CoolCalc. You can find it at coolcalc.com. Um, it's free to use to get the load. It's just you have to pay for the report. You won't need the report. And I would use CoolCalc in conjunction with this of just playing around to kind of get the sense, to get the feel for it. And I missed a question right up here of, let's see, when was that? A few minutes ago. Why are you making assumptions? Uh, well, if you're there for free and you're not being paid to do a blower door test. You're not being paid to check the house. You're not being paid to get those energy bills and disaggregate. You're not being paid to ask them a bunch of questions about how they use their house and everything else. You're making a lot of assumptions. And so if you're there to change equipment that is going to require sizing, then it's not a question of is there an assumption going to be made? It's who's going to make that assumption, and are we okay with it?
It's comparison, comparison to houses in our experience would fall under that. Yeah.
Okay, I see the angle yet, and
Uh-oh, called out.
The only time we like our water is when it's at the lake, okay?
Yeah.
Don't be coming at me. We like it simple down here. We like a simple air sourced heat pump. No more. Start adding any more fancy gadgets, it just gets bad. Nobody likes it.
Yeah. Yeah. What are the benefits you feel you're getting from a water-based system?
No problem.
Yep. Thanks for your questions, Corey.
Yes, thank you.
Yeah.
And thank you, Richard.
Oh, and so the off the top of my head, the three we mentioned at the beginning that homeowners are doing load calculations of their own. So the three that I can think of, Tanner's mentioned Cool Calc. There is the Quick Model DIY offering now. That's QWIK model, Quick Model 3D. You can go to them, and loadcalc.net are the three that I know of. Do not rely on the ones from the orange big box stores that tell you with 5 questions what size equipment you need.
Yes. When you see those, you just yell slurs at them until you can't see it anymore. Well, we're getting pretty close to an hour and 10. So I guess if nobody else has any more inputs, questions, comments, or anything like that, we may go ahead and wrap it up.
Against Alabama.
Yeah, more accusations.
All right.
Thanks, guys.
Yep. Thanks for everybody's input.
Yep. Thank you, everybody, and we will catch y'all on the next one next Monday.
Mm-hmm.